If I give you some overview about the second part of the lecture, we first talk briefly about how changes in interest rate or yield to maturity can affect the bond price. So in this example, we assume that the Bank of England raised the interest rate that will increase the interest rate for all. It's called level effect. So previously we got the 2.15% as a per period yield to maturity discount rate. In this case, it increased to 2.18%. Now then, because of the changes in discount rate, we're gonna recompute the present value. The present value becomes slightly less than before. The higher yield to maturity means lower bond price. So this is the price we're gonna get like this every period. Because of the changes in interest rate or yield to maturity, we're gonna get different price. So if you sell this University of Manchester bond, you buy it here. If you sell this one before the maturity, you will lose or gain because of this. When the yield to maturity increase, you will lose because you're gonna sell with a lower price. So that's the one reason of getting the changes in price. The second reason we were talking about was the saw-like pattern. So we briefly talk about which bonds are more sensitive to interest rate change. It turns out shorter maturity bond and high coupon bond they are less sensitive because the cash flow received soon are going to be less affected by the changes in interest rate. Anyway, we talk about this one and then we assume yield to maturity is constant, and given that situation, still we are able to see some changes in bond price. So let's use this simple example. So consider a 30-year bond with 10% coupon rate. So every period, every 1 year, we're going to get $10. At the end, we're going to get face value $100 and $10. The initial price for this bond is going to be 176.86. We use this simple annuity formula to get the premium. So your return is coming from two parts. First part, the converging of this bond to the face value. So in this case, since you're buying premium bond, you're gonna lose a little bit every period. Remember, we assume yield to maturity is constant. So even in this case, the bond price will converge to the face value. Now, when you sell this one before maturity, we have to think another one, the so-called accrued coupon payment. Let's say you buy this bond initially, the issuance. If you hold this bond for 1 year up to t is equal to 1, you're gonna get £10 coupon. Let's say as an initial owner of this bond, let's say you sold this bond after 6 months and you want to compute the return. Again, return is coming from two parts. Changes in present value, so you pay the price initially. That price will change because of the changes in present value. Go this way, you have the same cash flow but with a slightly different discount period. Anyway, so there will be changes in price value, changes in present value or price because of this effect. You get a lesser discount period for the same cash flow. That's one effect, the first return component. Second return component is coming from because of you have been holding this bond for 6 months, you will be able to get the part of coupon. You should get the part of the coupon here when you sell this bond to the new owner. So we're gonna call this part as a clean price, and we're gonna call this part as the accrued interest, unrealized, accrued interest from this coupon payment. If you sell here, you're gonna get half coupon. So the new buyer should pay this both term to you, the initial owner. The price they are actually paying, the new investor is paying, we call that as a dirty price. And we call this part as clean price, and this part as the accrued interest. Anyway, now this accrued interest rate will look like this. So we are assuming something like this. Initially, since you didn't hold this bond for any period, let's say you sell this bond here, you should get zero accrued profit. If you sell this bond after 1 year, at this point, you should get $10. We're going to use this linear scheme. So if you sell this bond after 6 months, you should get only half. If you sell this bond after 3 months, you should get only 25% of the coupon. If you sell this one after 9 months, you're going to get 75% of the coupon. So what's going to happen is if you sell this bond here, you're going to get present value of this bond cash flow plus £5, the dirty price. Let's say what's going to happen on this date, so-called X coupon date. X coupon date, let's first think about how to get present value of future cash flow at this period. At this period, so if I reinterpret this period as 0, this bond, because 1 year has passed, now the number period is just 29, and cash flow will happen next year up to t is equal to 29, right? So what is the present value of this one? Present value of this one, we're gonna use the same annuity formula, ending at the present value. We only use the 29. So 175.71 is the present value of future cash flow at this point. Likewise, we can get present value of future cash flow at this point, at this point, at this point. That's the clean price. That's how we get clean price on each X coupon date, each day where you get the coupon. Now, what about the dirty price? So initially, at this point, accrued is equal to 0 because if you sell this bond here, you didn't hold this bond for any time. What you're gonna get is just the present value plus 0. Dirty price here is the same as clean price. Now, let's think about the dirty price and clean price on the first X coupon date. Just before this coupon date, if you sell this bond just 1 day before the X coupon date, you should get the two things. First thing, the present value of all future cash flow, which is clean price you compute here, plus the $10 accrued interest. Now remember, this accrued interest always goes to the current owner. You sell your bond here, you didn't get $10 coupon from the bond issuer. You should get that from bond buyer. This bond buyer will get $10 from bond issuer here, so no problem. Anyway, so right before the X coupon day, the buyer will pay the present value of future cash flow plus the coupon. The $10 initial seller owner should get. So the dirty price is going to be clean price plus accrued interest $10. So right before X coupon date, this is the price seller should get. Now, right after the X coupon date, we need to compute accrued for the next coupon. At this point, just like this point, for this coupon period, you didn't hold this bond for any period here. Accrued coupon should be 0. Accrued coupon should be $10 in the next coupon date. So we see this sawtooth-like pattern. Dirty price should be equal to clean price plus accrued interest. The clean price is the one about the present value things. So if you buy the premium bond, eventually you will lose a little bit every time because you pay too much for the present value. But because of coupon, you will get certain return from that. The present value term, so you have two return components. The present value component will slowly going down, converging to face value, and there's a pattern coming from this accrued coupon things. So even without any changes in yield to maturity, we should expect to see this pattern. If you buy discount bond here, so you get the less than face value, eventually present value component will converge to face value, so you should get some gain from there. This is for the zero coupon bond. So the zero coupon bond, there will be no sawtooth-like pattern. You only get the increase in present value. For 3% coupon rate case, you have discount coupon. So there will be increase in the bond price toward face value, the capital gain, plus sawtooth-like pattern because of coupon payment. Anyway, the two things are observed here. First thing, always the premium price or discount price should converge to face value. First return component. Second part, because of the coupon payment, the bond price will increase and goes to 0, will increase, goes to 0, will increase, go to 0. So this just reflect the accrued coupon part. Now in reality, we should see the changes in yield to maturity, and we need to combine that with this sawtooth like pattern. So the actual price will look like this without changing in yield to maturity should look something like this green curve.